Let's look at the remainder theorem. Okay, what actually is the remainder theorem? Well, I've written it down here for you, so you can copy it out as well if you want. So the remainder theorem states that for a polynomial f of x, when f of x is divided by ax minus b, the remainder can also be found by substituting x equals b over a into f of x. In other words, the remainder can be found by finding f of b over a. How does that actually work? Well, I'm just going to remind you about this example here that I gave a few videos ago. It was when I was introducing long division. Okay, so the question was to find the remainder when this is divided by that, and the answer we had was this. We used long division to work out what this cubic divided by the linear term was, and the answer using long division was this, and there was a remainder. The remainder was -6. Okay, that was in a previous example. Have a look at the video again, okay, if you want. Okay. If we're just after the remainder though, we don't need to know this bit here actually. Okay, if we're just after the remainder, all we need to know is the -6 bit. That's where the remainder theorem comes in. Okay, what it states is all we need to do is look at what we're dividing by and then substitute x equals 4. That is just to work out what f of 4 actually is. And that's it. Let's just go ahead and do that. So if we put 4 into this, we'll have 2 times 4 cubed. So that's 2 times 64, that's 128. Subtract 5 times x squared, so 5 times 4 squared, so it's 5 times 16, that's 80. Subtract 16 times by 4, so subtract 64, and then plus 10. Let's work out what that is. So 128 subtract 80, that's going to be 108, 48, plus 10 is 58, subtract 64, that's -6, isn't it? Okay, and there it is. You can see we got our remainder that way, -6, much quicker. Okay, what I want to show you is the similarity between that and what we've seen before, the factor theorem. Okay, remember the factor theorem was all about this ax minus b as a factor and f of b over a equals 0, okay? Whereas now we're talking about that not being a factor. It's not a factor if there's a remainder, is there? Of course, okay? You can see this does not factorise using x minus 4 because there's a remainder, okay? Well, in that case, what essentially you're doing is you've got a remainder of 0, if you look at it that way, okay? Divide a polynomial by ax minus b, and if your remainder of 0, that's simply saying the same thing as the remainder theorem, f of b over a is equal to 0. Okay. What we're saying here essentially is that the remainder is not 0, it's another value, for example -6, and if we work out what f of b over a is, that gives us our actual value. Okay. I'm hoping that made sense to you. There's another example coming up. Okay, here's another example then. Same as before, notice I've just change the polynomial, okay, that's all. So find the remainder when x cubed minus 20x plus 3 is divided by x minus 4 this time, okay? So there's two ways of doing it essentially. You can use algebraic long division if you want, okay? So what you need to do is do that divided by this, and then you get a remainder at the end. That's your answer, okay? But what the remainder theorem does for us is it takes out a lot of time and hard work in doing that. All we need to do is just to find out what f of 4 is, okay? So substitute x equals 4 into that, and whatever that answer is, that's our remainder. So 4 cubed, 64, and then 20 times by 4 is, that's going to be -80, isn't it? And then plus 3. That's all we've got to do, just work out what that is. So 64 plus 3 is 67, subtract 80, that's -13. That's our remainder, okay? And that's how quick it should be, really. Okay, so another fairly standard remainder theorem type question. When 8x to the 4 subtract 4x cubed plus ax squared subtract 1 is divided by 2x plus 1, you get a remainder of 3, find the value of a. Okay, so let's just have a look. This one looks a little bit more like the remainder theorem, doesn't it? Because you've got the 2x plus 1 and the ax minus b there. Okay, so basically what it's saying is that is divided by 2x plus 1, f of x is divided by this. Find the remainder by looking at f of b over a. Okay? So what we need to do is find out what f of -3 1/2 actually is. Okay, so from that, of course, you'd have x is -1/2, so f of -1/2. So substitute x is -1/2 into that. Okay, so let's just do this. So -1/2 to the power of 4, that would be positive 2, 4, 8, 16, so 8 over 16. Okay, let's just write like that for the time being. I know you can simplify it, but I'm going to write it like this. And then subtract 4 times x cubed. So -1/2 cubed, that's going to be -1/8. So that's going to be plus 4 over 8. Okay, and then ax squared, -1/2 squared is +1/4. So that's going to be plus 1/4 a, and then subtract 1. And we're told the remainder of that is 3. Okay, so all of that has got to be equal to 3. Okay, so that's that. Let's just simplify it a little bit. So as I said, this bit here can simplify. 8/16 is just 1/2. 4/8 is also 1/2. And so what we've got is 1/2 plus 1/2, subtract 1, 0. So you end up with just, let's write it over here, 1/4 a is equal to 3. Okay, and so times both sides by 4, your a is equal to 12. Okay, and that is it. Okay, that is it. Hope you found it helpful. I'll see you again.